In our previous lesson, I showed you how we can implement HateOS inside of our RESTful API. We added hypermedia links to our API responses, and we also mentioned that this essentially represents a different media type than application JSON, which is what we are returning to our API clients. So in this lesson, we will talk about content negotiation inside of our REST API. I'll show you how we can introduce custom media types to support different representations of our resources, and we'll also touch on the idea of how we could use media types for API versioning. So why do we need content negotiation in the first place? All resources inside of our REST API map a specific request to our respective response. The problem arises when one HTTP request maps to multiple representations inside of our API. And in that case, the server needs to do content negotiation on behalf of the client, where the negotiation part is more close to selection because the server simply decides what is the most appropriate content type to use for the response. Here's something that Roy Fielding had to say about media types. A REST API should spend almost all of its descriptive efforts in defining the media types used for representing resources and driving application state, or in defining extended relation names and/or hypertext-enabled markup for existing media types. So according to Roy Fielding, using media types to describe the responses of our API is a valuable use of our time. Our API documentation should cover the custom media types that we have in depth, with as much examples as possible. Here's the representation of the response that we get when we query our habits resource. It contains a top-level property called items, where the individual habits are, and then it also includes some pagination metadata and our hypermedia links. Now, the default content type inside our application is application JSON. And even though we serialize this as a JSON object and returned it back to our client, the client needs more information about what's present in the response. They need to know about the existence of the hypermedia links. They need to know that the actual resource will be present in the items property and not as a top-level element of the response. So using application JSON as the content type for this response isn't the most correct approach. We have also broken the uniform interface constraint, which is one of the 6 REST constraints that we discussed in our first chapter, and the specific sub-constraint that we broke with this change is the self-descriptive messages. If you recall, this rule says that each message, a request or a response, must contain enough information to describe how to process the message. Luckily, there's a very good way of how we can solve this. Other than the standard media types that we can use inside of our REST API, we also have the freedom to define vendor-specific media types. You can also call them custom media types. And here's an example of what a custom media type might look like. We can use this media type to describe our representations that contain hypermedia links, which is why it ends with HateOS plus JSON. Now, our media type has a couple of specific parts. The first one is the top-level type, which is application. Then we have VND, which is a standard and it's short for vendor, and this is used to describe that this is a vendor-specific media type. Then we have our vendor identifier, let's call it devhabit, which is the name of our application, and then we have the actual media type name. In our case, let's call this the HateOS media type, and then we can append a suffix as an additional descriptor of what the media type represents. Now, when it comes to naming our media types, we have quite a bit of freedom here, as long as we document what each media type represents. Now let's jump into the code, and I'll show you how we can use our custom media type to implement content negotiation inside of our API, and we'll be able to use this to return different API responses to our clients. Let's start with an example. If I send a request to get the habits from my REST API, I will get back a JSON response. This is the standard media type that's used when we don't specify a specific media type. Now, we can also be specific by specifying a request header, and I can omit the one that's sent by default by Postman. And here I can specify accept, and then let's say we use application JSON. If I send this request again, we will get back the same response. So this is a supported media type, and we can use it in our requests. Now, what if I update this with my custom media type? For example, if I use devhabit HateOS plus JSON. If I send this request, I'll get back a 406 not acceptable response because this isn't a media type recognized by my API. If we go into the dependency injection class and we look at the add controllers method, here we are configuring Newtonsoft JSON as the default serializer for our API. And this includes some custom input and output formatters that control what are these supported media types. Now, application JSON is widely recognized and supported, but our custom media type isn't. However, we have a way to tell our application that it can use this media type. So a way to achieve this is to configure the MVC options object. I can say builder services configure, specify MVC options, and then on this object, I can access the output formatters. Let's say I say off type, and I specify the Newtonsoft JSON output formatter. Let me get the first value of this type, and I'm confident that it exists, so let me save it in a variable. And once I have my output formatter, then I can say formatter, supported media types, and introduce my custom media type by specifying the value. Instead of hard coding this, let's create a type that's going to contain our custom media types. So I'll create a class that we'll call custom media type names. It will be static, and inside of it I'm going to create another class. So this will be a nested class, which I will call application, and I just want to use this to represent the top level type of our custom media type. And finally, let me define a constant, and I will call this custom media type HateOS JSON. So now I can go back to our previous method, and here, instead of hard coding the media type, I can say custom media type names, application, and specify HateOS JSON. Now let's start the application again, and if I go ahead and send the same request with our custom media type, you will see that this time we will get back a response which contains the same result as before, but if we take a look at the response headers, you will see that the content type is set to application/vnd devhabit HateOS plus JSON. So now we are more accurately describing what is the response of our API. But we still aren't implementing content negotiation. It doesn't matter if I specify application JSON or our custom media type, the response that we get back is the same. So let's fix that next. I'll navigate to the habits controller, and here I want to be able to filter out the hypermedia links that I'm including here and here if the accept header isn't our custom media type, which is HateOS plus JSON. Now we can get this header value by simply specifying a string that represents my accept header, and I can bind this using the from header attribute and specify the header name. Now remember that we have our query type, the habits query parameters, where I can also do this by introducing a property, let's call it accept, and I can also decorate this with the from header attribute and specify that we should bind this value from the accept header on the request. Now if I go back to the controller, I can determine if my response should include the links, if this header has the correct value. The simplest possible way to solve this is create a variable, let's call it include links, and I'm going to say if the query accept value is equal to custom media type names, HateOS JSON, then you should include the links. If not, then don't include them. I also need to make a few adjustments. If I should include the links, then I'm going to pass in this function. Otherwise, I'm going to pass in null, and this won't include my links when I'm performing data shaping. And also here, if I should include the links, then I can set the links property on the pagination result. Let's also do this inside of our get endpoint, where we are fetching the single habit. I'll create a query parameter here that I will actually bind from the accept header. And then I can do pretty much the same thing. Right before I include the links in the response, I can say if the accept header is equal to our custom media type, then you should include the links that you have here. Otherwise, you can omit them. So let's start the application and test out the solution that we have. Let me first send a request without specifying our custom accept header. In this case, we will default to application JSON. And if I send this request, we get back a response, and you can see that the links property on our response is empty. If we wanted to also remove this property entirely, then we can configure this from our JSON options. Also, if we take a look at the top level response, you will see that the links are not present. Now, what would happen if I were to do some data shaping? Let's say I specify that the response should only contain the name and created add properties. If I send this request, you can see that our data shaping is working as expected, and the links aren't present in the response. Now let me specify the custom media type that we introduced and send the same request, And this time our data shaping is working, and we're also including the hypermedia links in the response for each of our resources, and also in the top level response when returning the collection of habits. And obviously the same applies when fetching a single habit. If I send a request to fetch one habit without the hypermedia links, then they won't be included in the response. If I include my custom media type and send the request, then the response will contain my hypermedia links. So you can see how we can use content negotiation to tell the API which resource representation we want to get back. Now I'm hoping that you're getting some ideas of how we could possibly use this to implement support for API versioning. I also want to make one remark about what we did when we introduced our custom media type as a globally supported media type. This means that we should accept this media type in all of our API requests. There's a way to further constrain what you want to accept or even return in your API responses using a set of attributes that are natively available in ASP.NET Core. If we specify the produces attribute, we can limit the content types that are returned from this API endpoint. For example, you can use the media type names class to access the JSON media type as the default media type, but you can also specify any custom media types. And if we use this approach, then we can omit adding our custom media type as a globally supported media type and only use it on the level of a single endpoint. We can also limit what we take in using the consumes attribute, and this can be useful if you want to have different media types for your API requests. For example, this may not be particularly useful in our GET endpoints, but it can definitely be useful in our POST endpoints where we have our request body. Using the consumes attribute, you can define different media types for the different API requests that you want to support on your API. This can also be used to implement API versioning on your incoming API requests. And this will be the topic of our next lesson, where I'm going to introduce you to API versioning on a conceptual level. We'll discuss what are the possible strategies for implementing API versioning inside of our API, and we'll discuss some of the implications of each approach and which one of them is the most correct one to use together with our REST API.